Hi, Math 050 students. Today we're going to be working with difference of squares. But before we start, I've got to put this inside my holder, and I've got a little joke for you. Okay? So this is my bunny rabbit who unfortunately seems to be scratching a lot. She's been laying around with my dogs. And so my joke is, what do you call a rabbit with fleas? So think about that as we're doing our difference of squares today, and I'll tell you the answer at the end of the video. And if you text that answer to me, then you're going to get some extra credit points, okay? Okay, so today we're working on difference of squares. So first of all, to talk about difference of squares, if you have your handout, you'll notice at the top of the handout, there's many perfect squares. So for instance, you can see it says 15 squared, and that's equal to 225. So of course what that means is, if you have your calculator handy, 15 times 15 is equal to 225. And also, if I were to put 225 into my calculator and then push the square root button, it's really hard to see it on my calculator. The square root button has the radical sign, so I just push that, and it gives me the square root, which is 15, okay? So if you were to have a problem like this, you would just say this equals 15, okay? And we would just solve it like this. The square root of 225 is 15, okay? Okay, so, excuse me, I have to cough. Sorry about that. Okay, so again, looking at that sheet, you have several radical signs, again, looking like that, with square roots, and they're called perfect square roots because I can just say the square root of 25 is equal to 5, and it doesn't end up with some decimal. So for instance, if you were looking for the square root of 6, so again with your calculator, use the number 6 and then push your radical sign, and you can see that you end up with 2.4494897, and it goes on, right? So this is not a perfect square. Notice, perfect, no decimal, not perfect, okay? Okay, so we're going to be talking about perfect squares when we're talking about a difference of squares. Another important thing to notice is the word difference. So when we're using a difference of squares, and I'll give you an example of one, you're going to have a subtraction sign in between the two perfect squares. So if I were to factor this, I would find the perfect square of x squared, which is x, and you think about this, x times x is x squared, so that's why it's a perfect square. So just 1x. Then I would use either a plus or a minus. I'm going to use a minus. And the square root of 49 is 7. Again, if you don't know that, use your calculator. And you put parentheses around that. And then you go ahead and make another binomial, only this time you're going to put the plus sign, okay? So x minus 7 times x plus 7 is the factor of a difference of squares of x squared minus 49. Okay, so let's be sure that this really works. So let's multiply x times x, which gives you x squared, x times a positive 7, which is a positive 7x, a negative 7 times x is a negative 7x, and a negative 7 times a positive 7 is a negative 49. Notice that when we add these two terms together, they cancel each other out because one is positive and one is negative. And so we end up with just x squared minus 49, which of course is what we started with, right? So that's why this sign has to be negative, because if you had a plus, it wouldn't be a difference of squares. And you would end up with 3 terms when you factored it back out instead of just the 2 that you start with. So, things to remember with the difference of squares: got to have a subtraction sign, and the first and the second term need to be perfect squares. Okay? Okay, so looking at your sheet, the first question that I have on there, number 1, is just x squared minus 25. So you figure out, okay, the perfect square of x squared is x, the perfect square of 25 is 5, and then you put a minus sign, and then you make the same binomial, only with a positive sign. So x minus 5 in one parenthesis, x plus 5 in the second parenthesis. Okay. And let's go ahead and look at number 3. So number 3, we've got y squared minus 121. Perfect square of y squared would just be y. Perfect square of 121 is 11. Now, if you didn't know that, that's the perfect time to use your calculator. 121, square root sign, 11 comes up. So you're going to have a negative sign, and then you're going to have a positive sign. Okay? Okay, and it doesn't matter the order. A lot of books give the answer with the positive one first and then the negative one. I just have gotten in a habit of writing the negative one first most of the time. Okay. So that initially is a pretty simple process, and this is not a difficult process, but sometimes the square root is kind of hidden. So if you look at example 5, we've got 6x squared y minus 24y. So just by looking at this doesn't look like a difference of squares, right? Because again, if we were to push 6 and the radical sign, you're going to get a repeating number. Or if you push 24 and the radical sign, you also get 4.8989794. So it goes on and on too. So these aren't perfect squares. X squared is a perfect square. So when you have a situation like this where you have a binomial and you're wondering, is there a perfect square hidden in there? What you do is you pull out common factors if there are some. If there aren't any, then it's probably not going to be a perfect square. So 6, of course, is a perfect greatest common factor. And y is also a common factor. So we're going to pull out the 6y. And then we'll make a parenthesis. So we have x squared left. And then this would be minus 4. So all we did was factor out the 6y. X squared minus 4, though, is a perfect square. So we could go ahead and factor x minus 2, and then x plus 2. Because 6y was a common factor, we go ahead and write it down in front of the parenthesis. Okay? All right, so let's look at another one. Let's look at number 6. So number 6 says 2x squared minus 18y squared. Greatest common factor, 2. So we factor out the 2. Y squared is a perfect square. 9 is a perfect square. Y squared is a perfect square. So this would be a difference of squares. The square root of x squared is x. The square root of 9 would be 3. The square root of y squared would be y. So I'm going to put a negative sign, put the parentheses around it, and then I'm going to write the exact same set of numbers, only with a plus sign. Okay? Okay. All right. Let's go ahead and look at number 8. So number 8, we have 9x to the 4th plus 81x squared. So 9 is a difference of squares, or it's a perfect square, right? 9 is a perfect square. X to the 4th could be a perfect square because any even number is going to be a perfect square. You just divide it by 2. So 4 divided by 2 would be x squared. I could also show you that x times x times x times x. So this would be 1x, that's a perfect square, and this would be a second group of x that's a perfect square. So you would actually be able to square out x squared. Okay, 81 is a perfect square, 9 times 9. X squared is a perfect square. But this binomial is not a difference of squares because, it has a plus sign. And it has to have a negative sign in between the perfect squares in order for it to be a difference of squares. We could factor this because it does have common factors of 9 and x's, so you could factor it. You could factor out 9x squared, then you would have x squared here plus 9. That's still not a perfect square though, and so that would be as far as we could factor it. Okay. Okay. So, let's look at your worksheet again, and let's look at number 9. So number 9 has 32 x cubed y minus 18 x y cubed. Okay, so of course 32 is not a perfect square, and neither is 18. But we do have that difference. We do have the subtraction sign. And so what we could do is look for greatest common factors. And so 32 and 18 both have 2 as a common factor. And I think that's it for common factors because 32 doesn't have 3 as a common factor and 18 doesn't have 4. So yes, 2 is the greatest numerical common factor. So we'll factor that out. Both terms have an x, so I'm going to factor out an x, and they both have a y. So greatest common factor, 2xy. So 32 divided by 2 is 16. 3 take away 1 exponent gives me x squared. 18 divided by 2 is 9. There's a subtraction sign there, so I'm going to put it down. And we've already pulled out the x. 3 take away 1 is 2, so we've got y squared. Does this look like a difference of squares? It sure does, because 16 is a perfect square, x squared is a perfect square, 9 is a perfect square, and so is y. So it would be 4x minus 3y, and then we would write another parenthesis just like it with the plus sign, and then we would bring down our greatest common factor. Okay, we'll do one last one, and then I'm gonna leave you to your factoring. Let's look at number 11. So number 11 is x to the 4th minus 1. So x to the 4th minus 1 is a difference of squares, even though it might not look like one. If you notice on your sheet, I say that 1 is a perfect square. And the reason it is because 1 times 1 is equal to 1. It's also a perfect cube because 1 times 1 times 1 is equal to 1. So 1 is going to be a perfect square. X to the 4th is also a perfect square. You might remember that I mentioned, if the exponent is even, it's going to be a perfect square. And so to do that, we just divide whatever that even exponent is by 2, and that will tell us what the perfect square of that number is. So 4 divided by 2 is 2, so it would be x squared minus 1, and then another parenthesis, x squared plus 1. Okay, guess what? We can keep factoring because x squared minus 1, this parenthesis is also a perfect square. This is an even number exponent, and 1, remember, is a perfect square, and there's a difference. And so we can't do anything with the x squared plus 1, so it just becomes a greatest common factor. So I'm just going to put that out here at the beginning so we don't forget about it. And then I'm going to make my 2 additional parentheses. So remember, I'm factoring this part, so we don't need to rewrite this because I'm factoring that part. X squared, the perfect square, means it's x times x. Oh, there's a square there. Negative sign, plus sign. 1 and 1. Okay. And now we're finished because x squared, we squared x by itself is not a perfect square. So we have x squared plus 1, then we have x minus 1 and x plus 1. Okay, you will probably have a couple of those type in your factoring today in the homework. Okay, so that's all I have for you right now. If you have some questions, let me know, and we can do a Zoom time together, and I can answer your questions, hopefully. And sometimes I can even just answer them over the phone. Okay, so back to the bunny who has fleas. So what do you call a rabbit with fleas? Bugs Bunny. Ha ha ha, Bugs Bunny. Okay, so if you text me the answer Bugs Bunny, I will know that you watched the video, and that means I'm going to give you, let's see, let's do 10 extra credit points, okay? So 10 extra credit points. Okay. All right, I'll see you at the Zoom meeting. Bye-bye.